Welcome to homework.
Okay, so we have an electromagnetic wave whose electric field is given as E vector. Remember, the electric field is a vector quantity, and that is in ith direction, I hat 2.225 volt per meter. This is the amplitude, that is E naught, sine 0.077 meter per meter times G minus 2.3 into 10 to the power 7 radian per second t. So looking at this equation, we will have to find out the wavelength and frequency. Now first, let us compare this equation with E is equal to I times E naught sine k, the wave number k, g minus omega t. Alright, so for the first question, we need to find the wavelength. So to find the wavelength here, if we compare, then we get k is equal to 0.077 per meter and omega is equal to 2.3 into 10 to the power 7 radian per second. So first, the wavelength lambda is given by 2 pi upon k. Right, so if you plug in the values of k here, this gives me 2.73, sorry, 2 pi by k is 81.6 meters. Alright, so we are done with obtaining the wavelength. Now for frequency, we can use c by lambda, where c is the velocity of the electromagnetic wave. So c is 3 into 10 to the power 8 and lambda is 81.6. So this gives me frequency is equal to 3.67 into 10 to the power 6 hertz. Alright, the other way that you can find out frequency is, or you can also use this formula, f is equal to omega by 2 pi, and you will get the same answer. Okay, this will give the same answer. Now let's move on to part B, the expression for magnetic field. So for the magnetic field, B is equal to, the frequency and wavelength is same, right? So the direction, let's first see the direction. Now from this equation we can say that E is traveling towards G direction, the wave is traveling towards G direction, E is oriented towards I hat, right? So we know that the direction of wave, the electric field and the magnetic field are mutually perpendicular to each other. So the wave is along k hat, E is along I hat, so B should be along J hat. Alright, now E naught, instead of E naught we have B naught. Now we use the formula, let me write that here, E naught by B naught should be equal to C for an electromagnetic field, right? For an electromagnetic wave. So this gives me B naught equals to E naught by C. Now, if you calculate this, E naught is 225 and C is 3 into 10 to the power 8. This gives me B naught equals to 7.5 into 10 to the power minus 7 Tesla. So plug this value here. So B is equal to J hat 7.5 into 10 to the power minus 7. This is in Tesla. Now what else? Now the sine term here. The sine terms should remain the same, isn't it? Because this is for the magnetic and the electric field, the frequency and the wavelength is same. So let me write this here and move this portion a bit on the left. Okay, so this is continued. Alright, so this ends the solution to this question.